Okay, let's look at question 3. So we have a demand function, a simple linear function which tells us the price the market will set at a given quantity level. We've been asked to find the firm's total revenue function. So we can treat this as though it gives us the price of an individual unit, which of course it does. But we want to know the total revenue. So revenue is always price times quantity. That's the price each unit costs. This is how many we sell, so that's how much revenue we get. So even in your little corner shop, this is the relationship with revenue. So price is, in this context, that. I'm going to put brackets around it because I'm going to multiply the whole function by q. So the brackets are really important. Otherwise, you only end up multiplying this term by q. So we now multiply q by every term inside the bracket. And 4q will become 4q squared because it would be 4 times q times q. So that's our total revenue. So that's our part A. B, find the marginal revenue. So marginal revenue is the same thing as the differential of total revenue with respect to Q. It doesn't matter how we write it. And that's differentiation. Remember, whenever we're asked for a marginal function, we generally always differentiate. So the task is to differentiate that function. So that becomes 105. If there's just a single Q, the Q disappears. And here we're going to multiply the power by the number in front of the Q, reduce the power by 1, as we always do. And that's our marginal revenue. C. We've been asked for the marginal revenue when Q equals 20. 20 units, 20 million, who knows? So when Q equals 20, MR equals 105 minus 8. And now wherever we see a Q, we're going to substitute 20. So that's going to be 105 minus 160. And that, so this is a bigger number than that. So we're going to go into negatives. So the marginal revenue is minus 55. So if we produce at that level, we're getting negative amounts of revenue every time we add a new one. D, using the total cost function from question 2, I'm going to have to refer back to that. Find the total profit function. So I'm going to have to pause there a moment. Okay, so we now have the total cost function. We've been asked in part D to use that and find the total profit function. Now, hopefully you will remember that total profit, sometimes written as pi, we can call this profit, is always, and you're going to know this from your everyday life, it's always how much money you bring in minus your expenses. And it's the difference between revenue and cost that gives us profit. So we have a total revenue function because we've already calculated that. 105q minus 4q squared and minus this total cost function. Now remember, I hammered this in class quite a lot, I think. We need to put this in brackets because there's more than one term here. And we need to be really, really careful here because we're subtracting a function. That means we have to subtract every single term in it. And the upshot of that is that every term inside that bracket will get a change of sign. So this used to be positive, so now it's negative. This used to be negative. This used to be a drag on total cost, but now it helps in profit. So yeah, it was negative, so it becomes positive. 17 was positive, so it becomes negative. That's where most of the mistakes are made in these calculations. All right, now we collect like terms. Remember that expression from school? So we're going to put the q squares together, and look, there's minus 4 lots of q squared, minus 1 lot of q squared. So all in all, we've got minus 5 lots of q squared. And now we look at the q's. We've got 105 lots of q plus 5 lots of q. So overall, we've got 110 lots of q. And then we've got a minus 17. So we only put those terms together that fit together. We can put the q's together, the q squares together, the constants together. Now we need to find E. So that's our total profit function. So E, find the marginal profit function. So marginal profit, my shorthand is that. So marginal, whenever we ask for the marginal function, we differentiate. So here we go. We multiply the power by the number in front of the q. So 2 times minus 5 is minus 10q, and drop the power by 1. Here we've got 110q, so that just becomes 110. There's no power there to multiply by. And the constants disappear during differentiation. So that's all we need to do for part E, so we're getting there. Part F, as a consultant, you have been asked to advise the firm on how much they should produce or sell to maximize profit. What would your advice be, and show how you derived it? So if we have this profit function, how are we going to work out the optimal level of production to operate at to give us as much profit as we can? So if our profit function so how do we find the maximum profit? As always, we set the marginal function equal to 0, because we are interested in the point in the curve where the gradient is 0. And that, if we set it equal to 0, we can then find the value of q which maximizes profit. So we've got minus 10q on this side. We'd awfully like q to be positive, wouldn't we? So we're going to move q to the other side. And remember, when we move a term to the other side, its sign changes. So we now know that 10q is equal to 110, but we're not interested in 10q. We're interested in 1q. So how do we find out what 1q equals? Well, because q is multiplied by 10, we divide by 10, because they then cancel out. And then we get a single q on this side. And 110 divided by 10 is 11. So as consultants, we can tell our clients that they should be producing at a level of q equals 11.